So we have to prove that at low damping, the quality factor of a circuit that's maintaining forced oscillations is approximately omega naught by delta omega, where omega naught is natural oscillation frequency. And delta omega is the width of resonance curve at the height at which current is root 2 times less than the resonance current amplitude. So first of all, at low damping, if we have these forced oscillations, that means we have some external frequency. So if the damping is low, that means beta is less. And if we are maintaining these forced oscillations at low damping, that means the external frequency is almost same as the natural frequency. So there are a lot of frequency terms here. So before proceeding in the problem, let's clarify that. So in this problem, we have three types of frequencies. One is the natural oscillation frequency of the circuit. That has nothing to do with the external omega. And it's nothing to do with resistor also. So in a pure LC circuit, we have this natural oscillation frequency that is given by 1 by root LC. But a pure circuit is never there, so we have some damping. So actual frequency of the circuit becomes root of omega naught square minus beta square. So let's represent that by term omega. Then we have external source frequency. So let's represent that by omega dash. So we need to find the quality factor at low damping. So let's get that first in general terms and then we'll try to solve it. So quality factor is pi by lambda. Lambda is beta t. T is 2 pi by omega. So this omega is this omega. So we take that up. So this becomes root of omega naught square minus beta square by 2 beta. Now if damping is low, beta is small. So this can be approximated to omega naught by 2 beta. So this is the quality factor. So you can see we already got a term of omega naught. Now we need to prove that delta omega is equal to 2 beta. So let's start with what's given. So he has talked about the graph. So let me just show you the graph first. So this is your current versus frequency graph, and he's saying that if this is the maximum current at resonance, now when current becomes root 2 times less, so that time whatever is the frequency, so the frequency is omega 1 and omega 2, sorry, omega 1 dash and omega 2 dash. So at that external frequency we are getting Im by root 2. So he's saying that this difference omega 2 dash minus omega 1 dash, that is delta omega, and that should give quality factor. So that delta omega should be equal to 2 beta. So let's see that. So it's given that at resonance the maximum current is Vm by R. So root 2 times less than that is our current now. So that is Vm by Z. So Vm by root of R square plus XL minus XL. Sorry, this should be XL minus XC whole square. Alright. So Vm will get cancelled. If you cross multiply, you will get R square to be omega dash L minus 1 by omega dash C whole square. Now, I need the term of beta. So let's introduce beta by taking the L out from here and taking it on this side. So this becomes R by L, and we know R by 2L is beta, or R by L is equal to 2 beta. So 2 beta is plus minus omega dash minus omega naught square by omega dash. So let's continue. So if you cross multiply, this will become this. So let's continue on next page. So 2 beta is equal to plus minus. We can rewrite it like this. Now, because the damping is low, the curve is sharp. And if curve is sharp, these terms will be close to each other. So omega dash and omega naught are pretty close. So we can write this omega dash plus omega naught to be 2 omega dash. So that we get rid of this omega dash. So we get 2 beta is equal to plus minus omega dash minus omega naught. So now, what is omega dash? So omega dash either is omega 1 dash or omega 2 dash. So on plus minus beta, so let's say on plus beta, I am getting the term of, so not we are not assuming anything here. So of course, if we take omega 1 dash here, so omega naught is greater than omega 1 dash. So omega naught minus omega 1 dash is equal to beta. And if I take this gap, then omega 2 dash minus omega naught is also beta. So if we add these two terms, we are going to get omega 2 dash minus omega 1 dash is equal to delta omega, and that is equal to 2 beta, and that's what we wanted. So from this equation and what we already saw, that quality factor is omega naught by 2 beta, we get quality factor to be omega naught by delta omega. Now let's see some interesting things from this current frequency graph. So what we saw here is omega naught minus omega 1 dash, this gap is equal to omega 2 dash minus omega naught is equal to this gap. So these two gaps are equal. And that's very surprising because this graph is asymmetric. But visually you can see that because the curve is sharp, these two gaps are almost equal. Now just to compare, I have added another graph with high damping. So here you can see the peak will still be at the same level, let's say. But now you can see if I go for Im by root 2, so at any level, you can see that this gap between omega 1 dash and omega naught is less than the gap between omega naught and omega 2 dash. But when the damping is low, these two gaps are equal. And also another interesting thing is we have already proven in 4.131 that regardless of the value of beta, so regardless of how the damping is, omega naught is always root of omega 1 dash omega 2 dash. So that is true in case of low damping. So omega naught is root omega 1 dash omega 2 dash here, and it's also equal to root of omega 1 dash omega 2 dash in case of high damping. But in low damping, we have just seen that this gap is also equal to this gap. So you know AM is equal to GM, right? So that AM becomes equal to GM when this curve is pretty sharp and these gaps are equal. So we have already proven this, okay, and we can see in the diagram too that with the low damping, as the peak becomes sharper, omega naught, which we know is omega 1 dash omega 2 dash root, is equal to omega 1 dash plus omega 2 dash by 2. And otherwise, because this GM represents the minimum value, so you can see for high damping, omega 1 dash plus omega 2 dash by 2 will be greater than omega naught. So some mathematics here, some nice mathematics that you can see from this graph. Otherwise, anyway, we have proven this quality factor to be this. All right.